Okay, this is video number 2 for the factor and remainder theorem, and we're going to look at applications of how we're going to use it. So if we asked you to factor a function that you weren't quite sure how to factor. So if you look at this and you say, okay, there's no GCFs. If I combine these two and I take out an x squared, which is their greatest common, and I take out a 9, your leftovers within both of these are not going to be equal to each other, and so therefore you can't do it by grouping, okay? So there's lots of different possibilities there. So then what do you do? Okay, well, this is one of your options, is to find one of your factors or zeros and use synthetic division. So we have one of them given to us, okay? So they're telling us that -3 is one of my x values in which the function is equal to 0. That's what this says right here. So I'm going to use -3 as my number that I'm going to divide by in synthetic division. So that goes out there. My numbers from the polynomial go in here. So x to the third means there should be 4 different terms in here. My x to the third coefficient is 2, x to the second coefficient is 11, x to the first coefficient is 18, and x to the 0 coefficient is 9. Always check those things because you never know when they're going to be in a different order or they're going to skip something. So we bring the 2 down here, multiply, you get -6, add, you get 5, multiply, you get -15, add, you get 3, multiply, you get -9, add, you get 0. This is the same one we did on the front side, so you should see that happening just again. Okay, now we have to do the extra part because here we're asked to factor, not to find if this is a 0. We were told that was a 0, okay, because we found that earlier. So knowing that we're factoring here, we have to work backwards. That's my remainder, so I leave that alone. This is my x to the 0 term. This is my x to the first term. This is my x to the second term. Remember when we write these, we never write the x to the 0, but that's just kind of a placeholder. And we don't really write the 1, we just write x. Okay, so this term right now is 2x squared plus 5x plus 3. And so that's what I have left over at this point. I'm going to keep factoring. I'm going to figure out how I can factor these terms right here. So if I'm looking at these terms in order to factor, I have a number in front. That means I either have to do the AC or the slide method. So I'm going to go ahead and do the AC method here. That means that we multiply 2 times 3 to get 6. And I'm looking for numbers that multiply to 6 and add to 5. Okay, so maybe I think about 6 times 1, but I'd have to make the 6 positive, the 1 negative, and that would make this a -6. That doesn't work. So 6 and 5 are always tricky because there's either 2 and 3 or 6 and 5. In this case, 2 times 3 is 6 and 2 plus 3 is 5, both of them being positive numbers. So that's what we're going to use here. With the AC method, you split up this middle term. So this is 2x squared stays the same. The middle term, so it's an x term, becomes a positive 2x and a positive 3x, and my last term stays the same as a positive 3. Again, we're going through the AC method here, so if you need some extra practice, you can come back and look over this. Then you get to factor by grouping. So here's my 2 groups. What is in common over here is a 2x. If I factor out a 2x, I have an x left over in that first term, plus, and 2x divided by 2x is not 0. There is a placeholder of a 1. You'll never lose anything in those. You always have something out front and 2 things in the middle. Plus, in these 2, we have a 3 in common, and then 3x divided by 3 is x, and 3 divided by 3 is 1. So this is good because in grouping, we need these to be the same. So now I'm going to factor out that x plus 1. So the x plus 1 comes out. If that comes out, what's left over here is a 2x, and then plus the 3 that's right there. So that's what we have. Now, a lot of you will say this is my final answer, which is not true. It said to factor this function. This is an x to the third, so you should have 1, 2, 3 answers. So you have to go back and think about what that third answer was, and that third answer has to do with this -3 that's here that we divided out earlier. All we did from here is factored this one. So this is the factoring of this part of the polynomial, okay? We're missing this factor here, and that factor is just simply the opposite, so it's x plus 3 is the factor, and that is your final answer for this problem. So x plus 1 times 2x plus 3 times x plus 3, in whatever order you would like. They do not have to be in that order, okay? Moving on to your next problem, it says state the real zeros of this function by graphing f of x, then find the 2 imaginary zeros. So we're going to graph this function to find the real zeros, and then we're going to find the imaginary zeros after we do that. So I'm going to go ahead and go over to my graph. We're going to add a new page and type in that function. So we're going to have x to the third plus x squared plus 2x and plus 24. Okay, so there's my graph. I can't see anything else, but really all I care about is that there's 1, 0. So that's right here. It looks like it's at -3. I'm going to check it just to make sure, because you never know. So we find that analyze graph 0, and it is at -3. So I went ahead and graphed it to find this 0. So by graphing, we found a 0 that was x equals -3. And then we're going to go from there to solve. So then find the two imaginary zeros. So I'm going to divide this number out of this term so that I can get it down to just what's left over. So I'm going to put that -3 out front, synthetic division. It's an x cubed is a 1, plus a x squared is a 1, an x term is a 2, and the 24 is by itself. That's your x to the 0 term. So there's your 4 terms at the top there in order. Bring down the 1, multiply, you get -3. Add these together, you get -2. Multiply, you get 6. Add these together, you get 8. Multiply, you get -24. Add those together, you get 0. Now, because we just checked this by graphing, if you don't get 0 here, you know that you did something wrong. So you were expecting the 0. What we didn't know is we didn't know what this all was going to be. So that's why we did the synthetic division. Work your way backwards. This is your x to the 0 term. This is your x to the 1 term. This is your x to the 2. Again, we don't write the 0, we don't write the 1. So this is simply x squared minus 2x plus 8. So again, we don't have to write the 1 out there either. So this is what we have left over. Now, it said then find the two imaginary zeros. So you can sit right here and try to figure out how to factor this, what multiplies to 8 and adds to -2, but you're not going to find anything that works because this is a positive 8, not a -8. So you have two choices here. You can either find your imaginary zeros by completing the square, or you can find your imaginary zeros by the quadratic formula. So I'm going to go through both of those options here and show you both of them. So quadratic formula, opposite of b is 2 plus or minus the square root of b squared, so -2 quantity squared, minus 4 times a, which is 1, times c, which is 8, all over 2a, so 2 times 1. So that's your quadratic formula. If we keep solving, we keep the 2, leave it alone. -2 squared is 4, minus, I'm going to do 4 times 1 times 8, so that's 32. And I'm going to do 2 times 1 on the bottom, and so that is 2 here. Keep solving, I'm going to solve the inside here, so I'm going to get 2 plus or minus the square root of -28 over 2. And then I need to simplify this square root here. So this is a -1, a 4, and a 7, and the 4 is a 2 and a 2. So -1 comes outside as an I, the pair of 2's comes outside as a 2, and the 7 is left over on the inside by itself. So that means that this is 2 plus or minus, again, the 2i comes outside, root 7, the single stays in, divided by 2. Now, looking at this, if you remember when we simplified, if all 3 pieces can be divided by the same thing you divide, and all 3 of those can be divided by 2. So divide by 2, 2 divided by 2 is 1, plus or minus 2i root 7 divided by 2 is just going to be I root 7. Fix that plus sign real quick. And then 2 divided by 2 is 1, so we don't need the fraction. And so this is, these are my two imaginary zeros. So state the real zero by graphing, so this would be one of my answers, and then these are my imaginary zeros that I found in another method. If you would like to complete the square, just to do this real quickly, you can come over here and complete the square. And what you're doing is you're completing it without an equation, so you can't move it to the other side. So this is where we added and subtracted. We're going to do minus 2x plus blank plus 8 minus blank. We need to fill this in by taking this number divided by 2 quantity squared. That's -1 squared, which is 1. You're going to factor these first 3 terms, so that's x minus 1 quantity squared, because it's x minus 1 times x minus 1, plus a 7 here, which means in this case we actually want, give me a second here, we want a minus a -7. So I'm going to rewrite that, because we take the square root of this and the square root of this, and that's going to be an x minus 1, and this is going to be a root 7i, and we write it with a plus and a minus. So this is x minus 1 plus I root 7, and x minus 1 minus I root 7. and that's your factoring. So this is how you factor what is right here. Then if you want the answers, it's what's going to make this equal to 0. So you need the opposite of both of these. So this one is 1 minus I root 7, and this one is 1 plus I root 7. And those are your two answers as well. So whether you do it the way that I did it with quadratic formula or completing the square, you're going to get the same answers either way. Okay, so you choose which one you want to do there. Just wanted to show you both. Move on to our last example here. This says the table shows one real root of the f of x function. That's a pretty long, big f of x function. Find the other roots. So we're looking for that. So it shows one real root. So you have to think about what does that mean? Root, 0, your solution, sometimes your x-intercepts are all here. So your real root is at x equals 0, x-intercept, okay, or when y is equal to 0. And so you find your x value. So that's -2. Okay, then you want to find the other roots. Now, good luck trying to figure out how to factor that. What we're going to do is we're going to use synthetic division with our -2 to get rid of that. We're going to do our -2 synthetic division to make this into a smaller polynomial that we might be able to deal with. Okay, so we put our coefficients in here. X to the 4th is 1, x to the 3rd is -2, x to the 2nd is -10, x to the 1st is 4, and x to the 0 is 16. Bring your 1 on down. 1 times -2 is -2. Add those together is -4. Multiply is +8. Add those together is -2. Multiply is a +4. Add those together is 8. Multiply is -16. Add those together, that's 0. Now again, if you didn't get a 0 here, something's wrong because it's telling us that one of the real zeros is there. Whether you picked the wrong real 0 or you did something wrong here, you know something went wrong. Okay, now we work our way backwards. Here's my x to the 0, my x to the 1, x to the 2, and x to the 3 terms, and then we write them out. So 1x to the 3rd is just x to the 3rd, minus, I have a 4x squared, minus, again, we don't have to write the 1, so minus 2x, and we don't write the x to the 0 ever, so then plus 8. Okay, now we have to find the other roots. So we have to look at this and say, okay, what can I do to find the other roots? And we want to do it, obviously, you can graph it, but we want to do it without a graphing calculator if we can. So if I see 4 terms, I'm immediately going to start to think grouping. Okay, so let's try it. Group my first 2, group my last 2, and see what we get. Okay, GCF for this is x squared. Take that out, you get x cubed divided by x squared is x, minus 4x squared divided by x squared is 4. Okay, here, anytime it leads with a negative, you always take the negative out, and there's a 2, so we're taking a -2 out. So -2x divided by -2 is a positive x, and 8 divided by -2 is a -4, and those do happen to come out to be the same, which is good. So we finish our factoring, so factor out the x minus 4, and then what's left over is an x squared minus a 2, and so that's our factoring right now. Now, we're just finding the other roots, we're not finding the factors, so I do need to keep factoring this if I want to go, but I'm just finding the, and again, it says other roots, so yes, -2 is one of them, but we need to find the other roots here. So this gives me an answer. If x minus 4 is equal to 0, add 4 to the other side, that x is equal to 4. So that's one of our other roots. And I can solve, if I have x squared minus 2 equal to 0, I can solve that by square rooting. So instead of factoring, I'm just going to square root. Add 2 to the other side, you get x squared equal to 2. Take a square root of it, and you get x equal to plus or minus, don't forget that, root 2. So we actually have 4, because it's a degree of 4, we should have 4 roots. We have 1, 2 roots, 3 roots, and 4 roots here in this problem. Okay. Last but not least, you just see at the bottom the different ways that this can be interpreted. So for a polynomial function f and a real number k, the following statements are equivalent. So if you're given k as a 0 of the function, okay, then that means that the function's equal to 0 at k. K is an x-intercept of the graph of y equals f of x, means that it's a 0. Okay, so you've got 0, you've got x-intercepts. X minus k is a factor. This is when we wrote our k as the opposite of what we saw here. Okay, so given a factor, our k was the opposite of what was here. Okay, and then x equals k is a solution or a root of the equation f of x equals 0. So that's saying if it's equal to 0, then that's one of the answers there. Those all mean the same thing. So you could see any of those. Okay, good luck on your homework.